here. I'm Prab Singh, and as Tom mentioned, I'm part of the ThousandEyes product team. I lead one of our core product areas around cloud and enterprise agents and collecting synthetic network data and the visualization that goes along with it. And I'm really excited to be here to essentially announce two key integrations now that we're part of Cisco, and also broadly kind of weave in ThousandEyes updates that you may have missed if you haven't been in the product like I am all day. So let's get started. For folks that may not be as familiar with ThousandEyes, I wanted to kind of do a quick overview of who we are, what problem do we solve, and then go into the respective updates. I think this image is a really good illustration of kind of the problem we solve and what we're seeing. A lot of our customers over time use ThousandEyes to solve problems. Generally, what we've seen in the past is, you have, or even today, as customers continue to migrate their infrastructure to consume SaaS, is, you tended to have applications that were deployed within your data centers. These could be business critical applications like SAP and Oracle. And you have a set of locations on the left-hand side where corporate traffic was originating and then traversing either your MPLS or your backup internet DMVPN to get access to those applications. And what we're seeing change a ton as these applications move to the cloud is sort of this increase in the wider dependency across the internet and across other third-party networks that are now really part of the extended network that corporate IT needs to understand and be able to ensure that users are getting the best possible experience of the applications. And this applies, regardless if the application is, moving completely to SaaS and being consumed as a SaaS subscription, or you have an application that's moving to the cloud via in one of the IaaS providers, and you have this middle mile that's the internet, and also now with cloud security gateways kind of becoming the extended network beyond your four walls that are now responsible for the end-to-end user experience. And what we realized also early on is the existing tool sets that existed and continue to provide a ton of value within the corporate perimeter, that be SNMP, flow-based solutions, PCAP-based solutions, have a ton of value, but they become less useful as the network becomes more widespread and complex across the internet. And that's really kind of the problem we were looking to solve is providing that control and visibility in an environment where applications are no longer in the perimeter, which actually also requires the network teams to re-architect the network to better serve users that are accessing these applications. And that's also requiring sort of a change in the security model to support these set of applications. And I kind of reference here, Ben Horowitz's paper from 10 years ago, talking about how software is eating the world. And we see this today where, software as a service is essentially providing added pressure to the IT teams to be able to ensure that they understand the true end-to-end experience when neither the application, most of the network, and the security stacks are now within your control. And that's required to kind of put added pressure on these teams to kind of work together and better understand the end-to-end user experience as you operate in this new world. And so that's the problem that we wanted to solve. Now, obviously, as Tom mentioned, we are now part of Cisco, and that mission continues. We see tremendous amount of value that we think we can provide customers. But now that we're part of Cisco, I think there's value in us being able to leverage the overall Cisco ecosystem to further accelerate how we can provide access to the visibility that ThousandEyes provides. And I wanted to walk through kind of the core pillars of our vision within Cisco. The first is kind of this around how do we make ThousandEyes agents as ubiquitous as possible across the corporate infrastructure environment. And I actually want to walk you through a story of how this evolves. I started the company about in 2015, And even at that time, Cisco IT was one of the earliest customers of ThousandEyes. And they use ThousandEyes to understand Salesforce performance. And we're having problems with return traffic from Salesforce to some of their corporate sites that are using Salesforce for their needs. They're also using ThousandEyes for understanding WebEx performance. And what became clear as we kind of moved beyond the pilot phase is kind of this need to deploy agents across the corporate environment. And this was hundreds of sites, but only 10 or 15% of the sites actually had compute to deploy agents, which are really kind of required to be able to run the synthetic tests that you need to get the visibility. And that's when we kind of started through the earliest conversations with Cisco IT and Cisco in general to be able to host ThousandEyes agents on a Cisco ISR at that time that had just come out with the capability of using app hosting. And so we worked with them and certified our agent to be able to deploy on a Cisco ISR so that the network teams can retain control and have a set of essentially hardware to be able to run the ThousandEyes agents and get the visibility that they need. And so we're really excited now that we're part of Cisco to essentially turbocharge that effort. And that's what we'll be talking a bit more in depth on. And how does ThousandEyes Agent become natively part of the Cisco Catalyst and routing infrastructure? The second element of the vision behind us becoming part of Cisco was providing this common operating language for application and network teams, where we can provide sort of this full stack domain isolation and problem resolution across the application or network and providing business context as we go. And again, this is something kind of grew organically as we worked with customers. We've talked about this in the past, where customers are using AppDynamics or New Relic or Datadog for their APM needs, but would generally have this growing set of third-party dependencies, where let's say you're a financial application and are reliant upon a third-party payment processor via an API. And there's this gap in visibility from wherever your application hosted to this third-party payment processor that needs to be accessed to be able to better serve your user that's actually using your application. Or you're a healthcare company and have part of your application stack served from AWS, but the authentication system tended to be on premise due to HIPAA requirements and others. And so you needed the visibility across your interconnect that's connecting AWS and data center networks, whether that's direct connect or internet. So you saw this growing need to actually understand dependencies that are beyond the application that are traversing multiple networks across your private LAN, and being able to provide data that ThousandEyes can help provide visibility gaps for those environments. And then thirdly, as we look to make agents more ubiquitous across the corporate IT landscape and make it easier for customers to get the visibility that they need, provide the ability to understand gaps in visibility across the full stack. We also want to take now the data that eventually we'll be able to capture and use that to power some of the decisions that eventually are their customers looking for, to be able to kind of drive decisions that help me better serve my users, regardless of the internet service provider or third-party dependency that I use. And so, having said that, let's actually walk through two new announcements and sort of the phase one of our early work within Cisco, where we've evolved. The first is what we announced at Cisco Live was the ability to deploy a ThousandEyes Enterprise Agent on a Catalyst 9300 or 9400 device to be able to provide visibility across your SaaS apps, across SD-WAN. We'll talk about that. And the other is across this common operating language, being able to provide ThousandEyes data to be able to understand these third-party dependencies in a single dashboard with AppDynamics Dash Studio. And for those that maybe aren't familiar with sort of the existing options that are currently have already existed for ThousandEyes, kind of talking about the the problem we were looking to solve with the Catalyst team at Cisco at the outset. We've had the ability to deploy agents in many different form factors for a long time, as you're seeing here. Customers are deploying virtual appliances in VMware environments in Hyper-V. They're using Linux packages to be able to deploy in Ubuntu, RHEL, CentOS environments. They're using Docker containers to deploy containers within your private LAN or AWS. And we also have an AWS-based AMI that allows you to launch a CloudFormation template to be able to deploy an agent in AWS. And while that was useful, the problem that we were running into that consistently is the time it takes to deploy an agent where I have to find compute and have to interface with server and virtualization teams is essentially delaying the amount of time it takes to be able to get spun up. And so we saw this opportunity where we can essentially partner with the Catalyst team to be able to make ThousandEyes agents native with a Catalyst 9300 or 9400 device. And so that's effectively what we launched. And so there are two parts of this integration. The first part is how do we make it easier for customers, any existing or new customer, to be able to deploy an enterprise agent on a 93 or 9400 device without requiring any additional hardware and provide the visibility that they need. Second is once they have the agent, how can you actually run the tests that you need by providing some ThousandEyes test capacity as part of their DNA subscription that goes along with the Catalyst 93 or 9400 device. So to talk a little bit more in detail about this, the agent is now able to run natively on a 93, 9400 device. And by natively, what we mean is no additional hardware required, where traditionally you needed an SSD to be able to install any application. The agent in this case runs on boot flash that already exists and generally will have enough space to be able to run the enterprise agent. The only kind of required element here is an iOS XE update to 17.3. If you're a new install, and by that we mean you purchase a 93 or 9400 switch starting April 5th, 2021, the agent is already embedded in manufacturing. So when the switch arrives at whatever site you're ordering this to, the agent Docker image is already there, and it just needs to be instantiated and spun up using either the CLI or DNA Center for the orchestration. If you're an existing install, there are multiple ways of getting the agent onto the 93 or 9400 using iOS XE. You can use a direct web link where we host our image and pull that down directly from the switch. If you don't have direct internet access, you can download it locally and upload it onto boot flash and be able to essentially make sure the agent is connected out to ThousandEyes. And the only thing that the agent really needs to communicate with ThousandEyes is essentially TCP 443 traffic out to ThousandEyes.com domains and subdomains to be able to authenticate itself and also get updates across types of tests it should be running. That's sort of consistent with how we've been operating the agent for a long time. We totally understand iOS XE upgrades aren't always easy. There are a long process that requires vetting across customers and users. But this is a one-time update only to be able to allow our agents to be installed in a 93 9400. In the future, all enterprise agent updates are independent of iOS XE, and that's an important point because generally, we ThousandEyes being a SaaS a SaaS subscription and operating a SaaS model, we publish updates to our agent and its capabilities every 2 weeks, and so there's the ability to essentially update your agent independent of iOS XE as you move forward and be able to use this at scale. For a certain set of customers, there's also the need to proxy connectivity out to ThousandEyes, and there's embedded capability to proxy its connectivity out to ThousandEyes for connectivity, as well as using proxies for testing to SaaS applications across your enterprise branch and data center networks. The only caveat to this is, one, requiring SSD when users need to run browser-based tests. And these are the tests that allow users to be able to render an entire web page or a series of web pages within the agent environment for application layer telemetry, and then correlating that down to the network. And so we call these page load and transaction tests that essentially have an instance of Chromium embedded on the agent, and they run in tandem with the set of network, the suite of network tests that we run. And for these types of tests, SSD is required mainly for the I/O requirements that are needed, and an additional resource-intensive based test cases that are needed for running our tests.
Strictly 93 and 94, or what about the 95K platform or the 9500s?
Yeah, currently we prioritize, the 93 or 9400. The architecture across the switching line, the Catalyst 9K switching line, is the same, so it allows us to be able to extend it out. We prioritize these mainly because these make up a bulk of the deployments, and also the use cases that we see across customers are, we need an agent as close to the user as possible, and 9300s are essentially at the access layer typically. And so most of the needs are really met with the 93 or 9400. 95, 600s is something kind of we're discussing, although that's kind of further out in the roadmap. But generally, we've seen that the 93 or 9400s are where most of the agent deployments are going to happen.
So the 9400s get the attention because they're often collapsed access distribution?
Exactly.
Okay, that makes sense. Thanks.
Mm-hmm. So yeah, let me walk you through the agent deployment on a Catalyst 9K through DNA Center. It's simply for kind of bulk agent management and be able to deploy the agent on bulk. You can also use the CLI for sort of lab environments, and also at scale using the Catalyst APIs to be able to kind of deploy the agent in bulk. When you're in DNA Center, you are using the provisioning service catalog to be able to access the app hosting catalog that allows you to run or deploy the ThousandEyes agent onto the respective switches that are available. And so you'll have sort of in DNA Center, you'll have the service catalog that'll have a series of application templates that can be deployed at scale across your Catalyst infrastructure. In this case, I have a predefined ThousandEyes template that includes the agent that was kind of uploaded into DNA Center. As I move forward through the deployment, the main thing that the template identifies is really, one, like how do we identify this agent and which tenant it belongs to in ThousandEyes, and that's done via an account group token. Don't worry, the account group token has been refreshed. This is because this was done prior to the meeting, so nothing compromised there. You can also, specify the host name if needed. Typically, we see this for kind of consistency across the corporate IT environment. And there are a host of other options like proxies and Kerberos authentication that are needed sometimes for customers to be able to make sure that the agent can authenticate through and talk to ThousandEyes. As I move forward in the install process, DNA Center actually has the ability to quickly help me understand which devices are compatible and to run the agent and which aren't by checking the iOS version, checking the sufficient amount of memory, the CPU and disk capacity that's needed. And in this case, you have the 9300-2 device that's ready for install. And so I'm going to go ahead and click next and go through the provisioning process of the application that, in this case, we need to specify the network that the agent container needs to connect through, specifically the VLAN. In this case, I've also defined that I'm using DHCP to be able to grab an IP for the Docker container that's going to be running. And again, the Docker runtime options there that you can specify to be able to run the agent. And essentially, once I go through the provisioning process and hit auto start the app, and I hit the application to be deployed, you'll see sort of a progress bar that deploys that. In the interest of time, I've actually gone ahead and deployed an agent myself. Once the agent myself prior to the meeting, And once the agent is there, what you'll see in ThousandEyes is sort of an agent pop up here that says you have an agent that's been deployed. Here's actually that agent that's been deployed. You can actually kind of see that it's running on a specific, Catalyst 9300-24T device that we're getting from the iOS and propagating all over the application. It's identified as sort of an Cisco application hosting deployment type. And more importantly, once the agent is installed, you can now go into the app and be able to actually run the relevant tests that you need across your environment. And so let's actually take a look at an interesting example of what can you do once the agent is on, let's say, a Catalyst device and you're running a set of tests. What can you do with the data that ThousandEyes captures? In this case, this is an interesting event that we recently ran into where we had an example where a set of devices were deployed in South America that are accessing key set of applications across my manufacturing environment. And there was sort of the set of kind of users that were complaining that these applications that my manufacturing team needs are not responsive, or we're seeing these problems recurring every day. And the network team needed to essentially come in here and try to understand where problems are occurring. And in this case, we have a set of manufacturing sites across 2, 3, 4, et cetera, that are named appropriately, where I was mainly interested in site number 2, where we're seeing reports of problems across my environment. And if I look at kind of the overall trend over time, you're seeing sort of this time of day where there's loss that's being observed. This is end-to-end loss from the agent that's residing within my manufacturing site, and that's going to a particular application, that's internal app on port 1521. And end-to-end, I'm seeing loss of 30, anywhere from 20 to 30%. I'm seeing latency that also shoots up if I actually look at latency during that time, as kind of is expected. If I actually look at kind of the path visualization then to try to understand where this is happening, and since I care about site number 2, I can look at I can filter out all of the information and specifically look at site 2's path to that application. And in this case, I'm seeing kind of where some of the delay might be happening, although that may not pinpoint to where the problem's occurring. One thing I do notice as I look at the data is I'm actually seeing a TCP maximum segment size and MTU mismatch, where the agent that essentially acts as a client in this network is sending traffic to the application. The application in its SYNAC response advertises a maximum segment size of 1460 bytes. But from the path MTU detection that the agent does, the minimum path MTU is actually 1441 bytes. And if I actually use some of the quick links, the path MTU is essentially decreasing across that link, which probably by just looking at the delay that's happening, it's probably across the WAN, and there's some sort of a tunnel possibly, although it's hard to know exactly what's happening. But I am seeing a decrease in path MTU at that time. That could potentially be causing this delay and loss. And if I actually go back and forward in time, I typically, what we're trying to do is try to identify in the path where is the source of this loss. And in this case, it's not directly clear where the loss might be coming from, although we do start to see kind of some white nodes that typically start to happen when we see loss and can pinpoint where. And one of the things we recently added is also the ability to pull in data from other applications that I'm also running from the same site. Because the problem that I'm looking to solve is this an application site-based problem, or is it a site-wide problem across every application? And so what I've done is actually use a filter that is only showing me the data that's being captured from site number 2. And I can actually start to add in data from those sites to see if I can somehow get to a better understanding of where the loss might be happening. And as I've added that, I've dynamically aggregated data across those tests to then try to identify, across a wider set of packets that are being sent at that time, where that loss might be happening, and then using sort of the visualization of ThousandEyes to kind of surface the source of where the loss was happening in this case. And what I'm seeing essentially is, most of the loss is happening across this node where it's unable to forward the packets. And it also happens to be that same link across which path MTU was decreasing. And I'm seeing sort of similar behavior across the applications. If I look at the table view and simply look at site number 2, and I group all the data by site number 2, and specifically look at the loss I'm seeing across all the particular applications that are being traversed.
So I've got a question for you. Actually, I've got a comment first, and then a question. I think the MTU visualization is great. That's like there is so much tedious work that goes into troubleshooting that. Normally, I think that's a great feature that you guys have, and in looking at the way you've laid out the flow and the hop by hop analytics. If I'm running like this, you said this is down in South America. I actually do a fair amount of work down there doing like ISP design. Like, let's say this is in Hong Kong and I'm running a dual stack network and I've got loss and I don't know if it's on V4 or on V6, or maybe it's only on one of them. Can the agent run in dual stack and see like, hey, maybe I'm clean on V6, but I'm losing it on V4 because maybe there's a congested CGNAT gateway? Are those types of analytics possible?
Yeah, so the agent is capable of kind of running dual stacked in dual stack mode, what I call. So it's capable of having an IPv4 and IPv6 address. It'll have, in this case, this agent is hosted on a particular network and it has a set of DNS resolvers. If the application that I'm trying to traverse has, let's say a quad A record, what typically we'd recommend is you run 2 sets of tests, one that forces IPv6. And so you're using the quad A record to traverse and target the IPv6 endpoint, and then one that forces IPv4. And so you can kind of combine, you use 2 different tests to try to understand if there is, IPv4, IPv6 based problems that could potentially be caused due to that nature.
Gotcha.
And the way we kind of, and the way we capture the data. Yes, these would be ad hoc tests that you'd set up separately. Otherwise, the agent will typically in the test settings of a particular test. So you'll have in advanced settings be able to identify, would you like the agent to prefer IPv4 if it has both IPv4 and IPv6 just records that it should try to target, or would you like it to force a specific protocol? And so typically for the basis of kind of comparing the two, what we recommend is you kind of force IPv4 and force IPv6, so you have both sets of data to compare against.
Got it. I think that's great. You guys have a strong focus on dual stack and looking at both sides of it. Thank you.
Yeah, absolutely. Now, I'd be remiss if I don't mention that we started working on the ability to deploy agents across the Cisco portfolio last summer as soon as it became clear that we're going to be part of Cisco. And the world has obviously changed a lot since then. And getting enterprise-wide visibility is only part of the picture. As we all now will work from homes and will continue to probably work from homes for the foreseeable future. I also wanted to mention how we can get further visibility from these work from home environments where you can't necessarily have an enterprise agent that you can deploy, but that makes up a very large percentage of the workforce that is needing to be able to access their applications. And we launched a product a few years ago called the Endpoint Agent. It was still in the early stages at that time. And in the last 12 months, it's become a lot more topical and relevant for our users that are looking to better understand kind of what is my end user performance from a work from home environment. How can I get a better understanding of the user's machine versus a local network versus their ISP versus the actual set of applications? And what's really interesting in this case is you essentially have to understand end user performance where none of the stack, the application or the network stack actually traverses the corporate boundary. The only thing that maybe the IT team can control is the actual end user machine itself. And so what we're seeing here is kind of the ability to capture data from what we call endpoint agents. that users typically deploy and our customers are deploying via group policy objects at bulk across all their home office employees. And the way Endpoint Agent works is, it runs as a dual part application that runs sort of a host system application. So for Windows or Mac, it's running a package locally on the host OS, and it has a browser extension that's paired with it to be able to trigger network data and local network data collection and local system information to be able to kind of provide that in a single view to understand end user application performance. And so we've made quite a bit of kind of changes to this application stack and this product to be able to better serve home office users. Now, by default, we don't collect any data because of obviously privacy reasons. And the IT team goes in there and specify a list of business critical domains that are worth collecting data against that trigger network data collection. There's also the ability to say, kind of just do scheduled testing regardless of browser activity. To say, I'd always like I'd like to get data across every 5 minutes across these set of 10 sites that I know I need for my users. And so in this case, what I'm looking at is kind of my employee base in this case that's accessing a set of applications that I care about. And I noticed sort of this dip in what we call the experience score that we capture by looking at various things like page load times, network latency, local network performance, and have kind of devised this experience score that helps you understand overall performance. And the idea here is, there's a user or there's a set of users complaining that they can't access an application. And in this case, that user was Acme in this environment. And Acme was complaining that their performance to Workday was actually suffering. And if we look at Workday in this case, we do see like page speed in general was worse at a particular time. And so let's actually take a look at kind of a deeper information into this user's experience to Workday. And what we realize, there's a wealth of information here about the end user itself around the fact that the user is, running on a Dell PC, their memory usage, their CPU usage, what browser they're using to access the application. You can see they're actually kind of wired in this case and going across a gateway. We actually also see that they're using AnyConnect to be able to connect to Workday in this case. And the public IP of the AnyConnect VPN is 185.83.57.98. And more importantly, what we also saw for Workday at that time is sort of this increase in kind of page load time that coincided with that time that the user started complaining that there's a problem. Now, if I filter down only to that user and Workday to kind of get a better understanding of what happened, I can actually look at the network to try to understand if that network latency was actually caused by some sort of a network change event, or is it something application-centric? And if I look at this view, I'm looking at specifically, Hans, my user, going to Workday, and I notice kind of if I go back and forth in time, let's actually take a look at latency. And, prior to this network change event, my traffic from Hans's network was going across my local network gateway that went across actually my home office network across, ISP, my Sonic, that eventually took me, seems like all the way through AWS, that eventually was serving traffic for Workday. And essentially it was CloudFront. And for whatever reason, this user decided to be on VPN and was using the VPN in this case. Let's take a look. Let me remove a particular network filter that I had. Was specifically using VPN at that time to be able to access this application. And actually, if I look at the underlay, I can also understand the underlay VPN performance at this time and be able to see by using the public IP of the VPN gateway that we can understand is actually see underlay performance across the VPN provider and then back across the VPN, which actually happened to be in the UK, to get to Workday. So this user that's in the San Francisco Bay Area is actually VPNing all the way to the UK and accessing a CloudFront instance somewhere, looks like in Amsterdam in this case, because it's exiting the internet at that time. And so we've seen, a ton of value in being able to use the data that's captured across work from home office users as well. And VPN tends to be sort of this number one root cause of problems where we need to really quickly understand, is there a VPN performance that's causing users heartache, and can we use that information to be able to very quickly understand sort of where problems might be occurring. It's kind of switching back to the second announcement that we made, and my colleagues will also talk in depth about what this integration is and give a demo here, is the ability to actually provide ThousandEyes data, the network data, and AppDynamics data in a single pane of glass to be able to provide that common operating language that we talked about. What we saw in our early days and organically across our customers is that we need the ability to understand user performance to the front door of the application, and then on the backside from the application to third-party providers that are typically being, and third-party payment processors or gateways that are being used, and dependency that are being used to better serve our users. And we saw this opportunity to actually use the data that ThousandEyes can capture and provide that data within AppDynamics Studio so that application and network teams can actually better serve their end users by trying to understand if the problem is actually on the application or a problem on the network. And so the integration that we worked on with across the application team, the AppDynamics team, was the ability to actually pull in ThousandEyes specific data across external services that applications rely upon into AppDynamics Studio, where you can have, let's say, a business indicator that's showing you information about your payment health and a payment gateway that's reliant upon a set of external services. And you see sort of this increase in payment processor backend times. And because you're pulling in test data live from within ThousandEyes, you're able to kind of quickly be able to see that there is sort of this change in external service performance that you can then launch into using the launch button and be able to verify where this network performance degradation is happening. This is sort of an example of what you typically see within the application flow map that AppDynamics typically captures that helps you understand sort of the end-to-end workflow. And there's this sort of the third-party payment processor that was seeing this increase in HTTP response times effectively, which ended up being sort of this AWS-based reroute where traffic that was generally being served from Ashburn is now going to Singapore to be able to serve. And that's causing sort of this increase in payment processor times that effectively is taking much longer for an end user to be able to process a payment, causing errors and timeouts.